Thank you so much for joining us today. Today, we're going to be chatting about the value of ultrasonic cleaning. My name is Anna Jardine. I'm Head of Education for SafMed, and I focus on all sorts of training relating to CSST and the operating room. Joining me today is Kurt Collison. Kurt, would you like to introduce yourself?
Sure. Hi, good morning. I'm Kurt Collison. I am the Senior Sales Representative and currently or recently the Surgical Product Manager position in the Western Cape area.
Thanks, Kurt. So together we're going to talk to you a little bit more about the value of ultrasonic cleaning. We'll share some of our technical expertise as well as some of the things we've seen and we've learned and we've experienced when dealing with ultrasonic cleaners in the actual CSST environment. Overall, our topics include why do we actually need ultrasonic cleaning? The fact that automated cleaning can be more effective than manual cleaning, and we'll talk to some of the published research on this topic. How do we use these ultrasonic cleaners? How do we look after these ultrasonic cleaners? How do they actually work? And then importantly, all the daily and the weekly checks and the importance actually of servicing this type of equipment. A very useful piece of equipment that sometimes I find is a little underutilized and something that we would like to correct because there is so much value in cleaning our instruments correctly, and this is one of those pieces of equipment that sometimes gets forgotten but can really do a good job. As of course I'm sure you all know that our surgical techniques have evolved over time. You know, back in the day, we used to have very simplistic instruments, knife, fork, and a spoon, maybe a hammer, and surgery was a little bit more, in some ways, easier. Now it's become a little bit more complex, but we've come up with these really amazing different approaches. We're making use of all of the technology that's out there. We use minimal invasive surgical techniques, as you know, and of course we started with using mostly 4 or 3 or so ports. Nowadays, we've advanced to the point that we can use a single site ports as well, or natural orifice transluminal endoscopic surgery, all these very unique approaches. I'm sure many of you are familiar with robotic assisted surgery. The Da Vinci is the model that we know the most in South Africa. Again, just one example of robotic surgical approaches. Now, some of the statistics are saying that 75% of all prostate surgery is performed using Da Vinci robotics. Absolutely amazing. With these minimal invasive techniques now, we found that these instruments can be quite difficult to clean, and ultrasonic cleaners can help us a huge amount when it comes to cleaning these. Did you know that in a statistic I read quite some time ago that over 60% of surgery performed in the US used minimal invasive surgical techniques? And we use it for all disciplines now. You know, we started off with laparoscopics and taking out gallbladders, but of course we use this minimal invasive approach with a multitude of our instruments. I want to just focus on the fact of complex designs, and it is true that a number of our instruments can be very complex, and this is a very interesting published paper, a paper published in the Journal of Hospital Infection. The title of it is Complex Design of Surgical Instruments as a Barrier for Cleaning Effectiveness and Favoring Biofilm Formation. I'm sure, as you all know, that once we get biofilm on a piece of equipment, or in fact in a catheter or a drain or anything of the sort, it can be very difficult to detect sometimes and extremely difficult to remove. Of course, with a biofilm is potential microorganisms. That's what, microorganisms themselves create these large patches of biofilms. In this particular research, they talk about the fact that manual and automated cleaning can, needless to say, reduce the amount of proteins and residues on all types of instruments. And they compared manual and automated cleaning and looked at some devices really carefully to see if there was any biofilm left on them. And in this research, they took an image of using a scanning electron microscope, and they detected soils and biofilms on some devices that in fact only underwent manual cleaning, but found the results to be a little bit better when the devices also underwent automated and ultrasonic cleaning. If you have a look at the image on the top over there, that was a depth gauge showing large bits of biofilm, patches of biofilm that had grown on this depth gauge. So I asked myself, how do you clean your depth gauges? Good question. Hopefully not just manually, maybe something that you need to think about in terms of putting into an ultrasonic cleaner. You all know, as I do now, that if we don't clean a device properly, of course, we're never going to get the next step of the process effectively done. We're not going to be able to high-level disinfect in some cases, or of course, sterilize those instruments. And that's where ultrasonic cleaners come in. They get into all of these nooks and crannies of these complex pieces of equipment that we just can't get into manually, and sometimes not even get into using a wash and disinfector. So they are a very unique piece of equipment. Well, how do they work? Okay, so you've all seen the bath itself. So we have a bath. Inside the bath, of course, we're going to put some water and some detergent. But within the bath are a whole number of components. We've got a device called the ultrasonic generator. We've got a component called transducers, and those transducers sit at the base of the bath. Of course, there are a multitude of other components. Kurt will talk to us or show us some of them a little bit later and describe a bit more of what those types of components do. But let's start with this. We've got a bath. Inside the bath is the water and the detergent. On the base of the bath are these transducers and the ultrasonic generator. What happens is that the ultrasonic generator sends a signal to those transducers. The transducers convert their energy into high-speed vibrations. And all of those vibrations create pressure waves in the water and fluid mix. The waves compress the water molecules, and when that happens, we end up with this implosion or cavitation process. So think about it now. You've all seen it, you've all heard the hissing. You switch the machine on, you hear that hissing sound. Now that's all of those hundreds and millions of little bubbles of water that are in bubbles that are formed in the water. And when those bubbles collapse, they implode. Looking at the image over there, you can see the graphic of a water molecule or water bubble now imploding. And when that implosion happens, it creates a bit of a shock wave. And that shock wave is what actually loosens all the swirls and the bioburdens. That's how they work. Remember all that hissing sound? You can hear it. You can imagine how all these little implosions happen. And that's what loosens all the swirl and all the debris in these really complex areas of the devices that we just can't get into. We can't get there with our brush. Looking at the base now, those little round dots that you can see over there, the red arrows are pointing to them, are the transducers. So you can see here we've got 2, 4, 6, 8, 10, 12 transducers sitting at the base of the ultrasonic cleaner. And that's to make sure that we get ultrasonics throughout the bath, that it's not just ultrasonics in one little corner or one part. So very important that we make sure that all of those transducers are actually functioning correctly. We get different types of ultrasonic cleaners. We get ultrasonic baths, obviously various makes and models and different sizes and volumes depending on what it is you need. They're absolutely ideal for flat instruments and stuff like our instruments. So they don't have any lumen flush. You open the lid and put your instruments inside and they clean the outside of the instrument really, really well. They will get into some nooks and crannies, but not necessarily irrigate lumens. Absolutely ideal for our instruments. We use smaller baths generally for our instruments, and we prefer, of course, to use a separate ultrasonic cleaner for our instruments. Then we can move on to ultrasonic irrigators. So that is a bath scenario that has both the bath normal ultrasonics that we refer to, as well as the ability to flush and irrigate with ultrasonics down a lumen. And then we get more fancier ultrasonic washer disinfectors that may be for bespoke types of instruments, some with dedicated cycles for Da Vinci. Some even might have a thermal disinfection rinse, again, depending on the make and the model. They all differ and vary. In fact, some very fancy washer disinfectors include ultrasonics within their cycle as well. That is also a possibility. Very expensive pieces of equipment, but very interesting. Let's look at this piece of equipment that you all know well. This is, of course, a Yankauer sucker. In research performed in the South African setting, 24% of all Yankauer suckers that were tested positive for residual proteins, which meant that they were not actually properly cleaned. Look at the design of the bulb of the Yankauer sucker. If you cut it in half, if I take a brush, I can obviously only fit a brush with a very small brush head into the back end of the actual Yankauer sucker or into the tip. But either way, a brush that'll fit through the lumen of the tip or fit through the lumen at the back end of the sucker is not going to be big enough to clean inside that big bulb section. And you can see over there how dirty that bulb is. Now, that's a device that's really only going to come clean properly if you use an ultrasonic lumen flush scenario. So let's have a look at ultrasonic lumen flush. So here's an image of a fine suction, and it's connected to the lumen of the sonic irrigator using a connector. This type of ultrasonic, as we said, will clean not only the outside of the device, but also flush with sonics down the lumen. Each make and model will specify the ultrasonic frequency as well as the actual pressure for flushing, but it can be at around 3 bar. Of course, very important to use the right size attachment so that you can secure the attachment correctly to the device being washed. A number of different types of instruments can benefit from ultrasonic cleaning, but certainly all focused on those complex devices. We know that our instruments are tiny, that the joint spaces are very small, and it is very difficult to get in there without cleaning properly. So again, we want a dedicated bath for our instruments. Illumined instruments, so anything with a lumen. As we said, we've got the sonic irrigation and the sonic flushing. Orthopedic instruments and reamers, for example. If you read manufacturer's instructions for use, of which we should all have, you'll see, for example, perhaps some orthopedic devices. You'll see specific requests or instructions for use that stipulate that those types of devices should in fact be cleaned using ultrasonics. Complex devices like Da Vinci, maybe some Arthrex type devices, and based on manufacturer's instructions for use, will tell you which type of instrument or which type of device actually needs ultrasonic cleaning. Very important that we follow those manufacturer's instructions for use. Remember now, when a manufacturer makes an instrument, they are obligated, it's part of the legal requirement, is they take the instrument, they inoculate it with a known amount of contaminant or microorganism, and they put it through some cleaning steps, and at the end of the day, they have to be able to prove to you that if you follow those correct cleaning steps, this device will now be clean. Very important to follow those cleaning steps, because if you're not following them, you do not know for sure that you have now a clean instrument. And a lot of instructions for use, in fact, will stipulate that the device needs to go into an ultrasonic bath. Right, so we need now a bath. What are we going to do? How do we install our bath? Kurt, can you give us some guidelines?
100%. Okay, so to install, the installation requirements of an ultrasonic cleaner will vary from brand, make, and model. And the example that we currently have on the screen starts off with that we need to have, with all ultrasonic cleaners, we need to start off with a stable and level worktop which accommodates the brand, make, and model. We also need to ensure that there's enough clearance around the ultrasonic cleaner. It's for ventilation. It's also for future maintenance work by technicians and storage of your detergents and your lower pipes and connectors. Then, depending on the make and model, like as I mentioned, the requirements may vary. So most of them, or most makes and models, will need the general needs, which will be electricity, drain, hot and cold water supplies. As the diagram that we have on the screen, it shows there's a drain, the detergent hose, that's because it's a fully automated system. It has the power supply from the plug, your hot and cold water supply, and it also has an overflow pipe running down to the drain.
What's an overflow pipe?
So the overflow pipe is there in case your overflow sensor or any of the sensors overflow. Also, if your tabletop is not labeled correctly and water is filling up, it might spill out. So the overflow pipe will eliminate water spilling out over the top through the lid seal and creating any issues of water or water on the floor.
Oh, excellent. So if there's any overfilling for some reason, or the table's a bit skew, the sensor will then activate and the water will overflow out the back into the pipe instead of coming forward or flowing onto the floor or into our CCSD.
Or into the sea, correct. So yeah, it's just it flows into the drain, and it's a fail-safe pipe for any of the sensors.
Excellent. So does it matter where we install? Can we just throw in some hot water, some cold water? What do we need?
So water requirements or supply requirements may also vary, and the example on the screen will show some numbers, but each break and model, the main thing is water quality. So don't only use cold water, it depends on the brand, the make and the model. It needs hot and cold water. It needs a good water quality. Hard water can affect the cleaning of the instruments. It can also create unnecessary breakdowns of the ultrasonic cleaner over time because of buildup of calcium in the water supply. The water pressure is very important. It needs to have the right water pressure for inlet water. So hot or cold water, they will be follow the instructions for use from the manufacturer, and they'll state what the water pressure should be. If you're looking in terms of flow rate is the amount of water coming into the unit at a specific time, and that will also vary. So if the flow rate comes in too quickly, it could create, some of the ultrasonic cleaners have certain sensors in the water level sensors, which we'll discuss later. And if it comes in too quickly, it will activate the sensors too early, or it will give you an error of overflow, or it will stop the process of the cycle. And then
Okay.
water, yeah, sure.
So all of these things are very important. We can't just throw the ultrasonic cleaner in a corner and hope for the best. The amount of space around it matters. The type of water, the quality of the water, the temperature of the water. If the water is too cold, what will happen?
So if the water is too cold, you will also, the machine first of all will give you an alarm if it's a fully automated brand and model. If it's a semi-automated where you fill up your own water and you don't maintain the instructions for use with the water temperature that's stated, it's going to affect the cleaning process of cleaning the instruments, because remember, the detergent that you use in the enzymatic detergent needs a certain temperature to actually activate and clean effectively. So too cold water won't work. If the water is too warm as well, there are machines that will create errors, or it will affect the cleaning efficacy or effectiveness of the ultrasonic cleaner.
So the water temperature could even end up aborting a cycle, or a cycle stopping a cycle from working.
100%. It will abort the cycle. A lot of the fully automated units, or the units I've seen the brands out in the market, they definitely abort the cycle if it's too cold or too hot.
Okay.
So the water temperature has to be in between the stated value of the manufacturer.
So that's actually a good safety feature. Obviously, if the water is too cold, you're not going to get good cleaning, or as we said, too hot, you might bake on the proteins almost. So a nice safety
Sure,
feature to make sure that that the water temperature is correct. That's
correct.
great. So Kurt, you work with ultrasonics quite often. You're in the field often. You're called out to help with breakdowns, or to assist if people are using the ultrasonic cleaner and something goes wrong. What are the things that you see? I know we put them together onto our slide. Take us through the things that you think are quite important when you're working with your ultrasonic cleaner.
Sure. So going through the tips that's on the screen, at least, we have the instrument manufacturer's instructions for use. And that's number one, is very, very important. We have a lot of times we will ourselves will put in instruments that's not validated, or the instructions we use on stating that it can't go in an ultrasonic cleaner, and you could of course damage the instrument. Then you have instruments that it's just with the detergent or the certain hertz of the ultrasonic cleaner, it's not the correct. Just as you mentioned, the EC noise that's measured in hertz, and if the hertz is not correctly, then you can end up damaging your instruments as well. So instruments instructions for use is very, very important, and you need to follow those protocols. The following one is removing gross soils. Although certain brands, which we'll discuss later, have and models have a pre-wash, we need to do a not pre-wash, pre-rinse. You need to pre-rinse prior to putting it into an ultrasonic bath or ultrasonic irrigator. It's just to make sure that we're getting the optimal efficacy of cleaning, and to make sure that the instruments, because that debris will end up lying inside your ultrasonic bath, and then you can cross-contaminate other instruments. So removing of gross soils is very, very important.
So, Kurt, you spoke earlier about some makes and models being semi-automated, some being a little bit more automated. So, if we use an automated one, for example, you and I know that some of those you'll take the instrument, you'll load it in the basket, start the cycle, and it'll go through 3 cycles. It'll do like a pre-rinse, a main wash, and a rinse again. And in those circumstances, you might get away with not having to rinse too much, maybe. But certainly, if you're trying to reuse the water, or you've got a semi-automated system, if you've got a whole lot of debris on the instrument themselves, from what I understand, that kind of almost dampens the efficacy. Is that correct of the ultrasonics?
That is correct. And like you said, if it's one that does not drain afterwards because it holds the water for the following wash, if we do not change the water, we of course have all the debris, and it's just going to be filtered back. We put in instruments in there and hoping it's going to be clean, and you have all this debris line at the bottom. So 100% it will affect the efficacy of cleaning and how clean the instruments are when they're coming out. And you need to make sure that it's pre-washed after. And even with a fully automated one, I know there's a pre-clean, not pre-wash, but pre-clean or pre-rinse. You still need to remove gross soils, even with the because the pre-rinse is very short.
Okay.
It will do a pre-rinse, it will drain out. But remember the filters that we'll discuss later. You'll see the filters. They're very tiny, and they're restricted. So it's more for filtering the water. But if it's huge debris or big pieces of debris, of course it's gonna lie inside that and clog up those filters very quickly.
Okay. So teach me a bit more about the degassing cycle. How does that work?
Degassing. Once again, with the various types of ultrasonic cleaners, as you mentioned, there's fully automated. Some of them have a degas phase in the cycle, and then so that degas phase is there to remove excess gas from the water. So water has excess gas in it, or certain gas, there's gas always in the water, and to ensure the cleaning process, and which you mentioned earlier with these tiny bubbles, and getting the cavitation correctly to the cleaning correctly in the ultrasonic cleaner, we need to do a degas cycle. So remove excess gas from the water. So the ultrasonic creates its own tiny bubbles, which will create the cavitation and clean the instruments correctly. And if there's extra gas in there, it will collide with these tiny bubbles, and of course reduce the efficacy of the cleaning.
So the
So
gases in the water will actually affect the cleaning efficacy at the end of the day.
that's correct. So
Okay.
if it's a manual unit, in the beginning of the first, so manual unit, this is how it happens. If you are going to be draining the water out during the day, every time you refill up water in the manual unit, you will run an empty cycle to do that's claiming, or that's technically your degas cycle. If it's an automated unit, it will have a degassing phase before the wash cycle.
Oh, okay, great.
Sure.
And rinsing?
And rinsing. So rinsing, if it's a manual unit, please, we need to rinse before we put it through a washer or moving forward with the instrument. It has to be rinsed off correctly. Make sure that there is no detergents on the instruments. If it's a automated unit and we have the correct cycle that we chose earlier, it will have a final rinse, which means it's ready rinsed and the water is drained out and it's ready to be put through an instrument washer or for its next phase.
Excellent.
Okay.
So, rinsing obviously to get off the debris, get off the detergent, etc. And hopefully, if we're doing our stuff correctly, we're putting our instruments from the ultrasonic cleaner then into our automated washer disinfector. Is that correct?
That's correct, yes.
Okay.
Okay, and moving on to number 5. So number 5, look, a lot of the ultrasonic cleaners or certain brands will have a sensor on the ultrasonic cleaner, so it asks to keep the lid closed. And keeping the lid closed during operation, of course, eliminates any aerosols being pushed out from the ultrasonic cleaner into the CSSD area and us inhaling that aerosols from the cleaning. So always keep the lid closed of the ultrasonic cleaner. A lot of them have sensors on it, so if you open the lid, it will stop the cleaning process immediately or the cycle and abort the cycle. But yeah, if it's a manual one, some of them are older, please do not leave the lid open. It creates a lot of aerosols. And
Okay.
then cleaning of the ultrasonic cleaner, always clean and disinfect the unit regularly. It of course prolongs the life of the lid. We'll discuss more cleaning processes in the next few slides. And please do not leave water standing overnight. It can lead to a buildup of endotoxins.
Exactly. And of course, we those that have scrubbed for hours will be familiar with TAS, toxic anterior segment syndrome, which our patients can develop. And TAS can be caused by endotoxins as well as detergents. I see you've got a point on number 6 about not mixing or certain metals and not doing certain types of items in the ultrasonics. Teach us some more about that.
Yes. So a lot of as in the manufacturing instructions for use, it will state what you shouldn't, and also the instruments manufacturing instructions for use, like I mentioned earlier, will tell you what can be put in an ultrasonic cleaner. But for the ultrasonic cleaners instructions, please do not mix the plastics or soft metal with each other, which meaning if you have if there's aluminium, stainless steel with brass or copper, the staining of the instruments and the metals can move over to the next one and it creates damage to certain instruments. It will also, of course, can damage the unit. So please do not mix those instruments. If certain, like the plastics that, like I said, cause damage during the cycle or it just prevents the cycle from cleaning correctly. And please do not put any telescopes or electronic items in an ultrasonic cleaner. It will damage the instruments.
Excellent. So even though we're doing laparoscopic instruments often in ultrasonic cleaners, we of course don't want to put in telescopes themselves, and we don't want to put in light guide cables or things like that. Again, like you said, following the manufacturer's instructions for use.
Yes.
So obviously, again, you spend time in the CSSDs. You see us using the pieces of equipment or loading instruments into the bath. Tell us about what the right processes are. Or tell us about the things that you've seen that have gone wrong.
Sure. So, okay, starting with number 1, wearing the correct PPE. We are always under pressure in the CSSD area. And we move from one section to the next. So moving from an instrument washer to the ultrasonic cleaner. A lot of times we forget to wear the correct PPE. We are on the dirty side of the CSSD and decontamination side, and we need to follow or wear the appropriate PPE. And this is to protect ourselves. So that's very important. Rinsing off gross soils, once again, we spoke about it earlier. All gross soils must be rinsed off the instruments before loading them. A lot of times, like as I mentioned earlier, we are under pressure. We pack the instrument straight into the basket. If whether it's connected or not, we put it in and we assuming the ultrasonic cleaner is going to do his job. And of course, it won't be coming out clean at the end of the cycle. Instruments going into into the basket. A lot of times I'll find, or if I'm in the sea, we find that the basket has been removed to either check in the morning, do the morning check for the filters, clean or dry the bath out, and we put instruments directly into the bath and not into the basket. This
So
will
somebody
cause
forgot to put
damage.
the basket back in.
100%. A lot of times we forget to put the basket back in, and or we put something that's too big for the basket, and we're like, hey, let's move the basket out and put the instrument straight into the bath. You damage the ultrasonic bath, the floor. You also damage the instrument because it shifts around, and it will create little hairline cracks in the ultrasonic itself. But then we mentioned not touching the floor. So instruments fully immersed, that if it's not fully immersed, then of course it will be either overloaded, that we load the basket all the way to the top. It's standing out of the water, it's not in the water correctly, and that is not correct. So I found a lot of times that that's also the issue. We have a lot of instruments, a lot of laparoscopic instruments. We try to get it all done in one cycle because the list is requesting that it should be back in the next 30 minutes or 40 minutes, and we load everything and it's not fully immersed in the solution.
Okay.
Then, yeah, sorry.
I was just moving on already. So
Oh,
I
yeah,
noticed on our slide we have already spoken about the mixed metals. So
yes.
we did cover that. I think we've spoken before about disassembling. I'm not sure disassembling. That makes good sense. If you take the instruments apart, so that we know that they're properly disassembled. And we
And
mentioned
the
a little bit
aerosols.
already about inhaling those aerosols, didn't we?
Yes, we mentioned that in the previous slide, inhaling the aerosols. If the lid is not closed correctly, during mid-cycle, we open it up to have a look. As we mentioned, if the list requires the instruments we want to see, we want to, how far is the cycle, is it clean, and the cycle is not completed. But we are opening up the lid.
And
And
then
that,
we expose ourselves to those aerosols. Remember, in those aerosols potentially is microorganisms that we, of course, can inhale. Um, I know I've done it before with you, where you're in a hurry or something, and you quickly open the lid. And I know in some of the makes of the model that actually aborts the cycle or something of the sort.
that's correct. It has a sensor, and it will trigger the that it's been open, and it will abort the cycle.
As a safety feature.
It's the safety feature, 100%. So earlier I mentioned that if the unit won't work, some of the units won't work without the lid being closed. So that's on the same safety switch that it has. So it's definitely a safety feature.
Oh, okay. But sometimes you can press like a pause button and then open the lid. Is
And
that correct?
and take a look inside. Yes,
Okay.
that
So
is
then you.
correct.
Oh, okay. Oh, very smart. All right. Thank you, Kurt. All right, moving on. I know you've taught me this before. Tell me a bit more about these sensors.
Okay, so on the example that we have on the screen, there are 3 water level sensors that you see on the left side photo or picture. And starting with the one right at the bottom, that level sensor will pick up if there's still water in the ultrasonic bath. The middle sensor is the fill sensor, and that sensor will stop the inlet water valves for water entering the ultrasonic cleaner to say the ultrasonic cleaner is at its optimal level and it's ready for the cycle. And the third sensor right on top is the overflow sensor. So not all models have overflow, so it varies from unit to unit. And this sensor will pick up if the water is bypassing, if the fill sensor failed, or there is too much, the flow rate is coming in too quickly, as we spoke about earlier, and it will trigger the overflow sensor. If all
So,
these sensors fail, you have the overflow pipe, which is a
okay,
safety
so
feature.
so just to understand, of course, this is now when we're dealing with an automated system. So here
Yes,
we put the instruments in, right? We press the button, and the cycle begins, and the bath actually fills up. Those sensors
correct.
now will tell the machine when to stop filling because now it's full. We don't need any water. If there's an error or an issue, and for some reason it fills up a bit too much, then there's another sensor to protect that. If it's really not going even beyond those sensors for some unknown reason, it actually all drains out through the overflow.
That's correct. Yes. So that's
Okay.
the final safety feature, and you won't have any spillage on your floor and
Okay.
in the CSSD. And then you mentioned automated. So a manual unit normally only have two sensors because you fill in it up manually, or up to one sensor. It really depends on the make and brand. So if you fill it up manually, it will tell you when you're at the
Full
the
level.
full level, and of course the sensor at the bottom will tell you when you're draining it manually that the unit is empty.
Oh yeah, of course we have to get the water out, and that's part of
When
that sensor at the bottom is to make sure that we actually drain the machine correctly.
That's correct. Then cleaning of these sensors. You need to maintain and clean them on a daily or daily basis. So using a soft nylon brush, which we'll find in the toothbrush towel that we find in CSSD, that to clean it, and then a non-greasy alcohol wipe for cleaning as well. This will prevent the buildup of any kind of scale on your sensors, and it could interfere with the machine's operation. So you need to do your cleaning process on these sensors.
Okay.
Then moving, yeah,
Yeah, no, I was going to say I'm looking at the image on the right over here, which we don't get to see often from this angle. So this is the bath with the basket removed now. Yes.
yes. So this is an example of a bath with the basket removed. So disposable filter, as you can see above that picture, there's a disposable filter. That's where the disposable filter will be placed, and that you need to make sure that you follow the instructions for use when you are changing the filters. It needs to be checked regularly and changed as stated in the manufacturer's instructions for use.
And that filter catches all the debris.
That filter will catch the debris. Well, okay, so that filter helps trap debris and keeps the system running efficiently. So with the irrigation, connecting up as you can see, there's docking ports. So if you have irrigation, this is a fully automated unit. It will stop the debris from going through the lower pipe and connectors and through any lumens. And that's what that filter's there
Ah,
for. So
okay.
it stops the debris from pushing through into your lumen devices and into the water
Okay,
manifolds.
now I get it. Now I
Yeah,
get
if
it.
they're
So,
connected correctly.
okay. All right. So that then traps all that kind of debris. So quite important that we check that every day and replace it as instructed.
Sure. And then also you'll find, as you can see on the below picture, you'll find the drain and the docking ports. So it's very, very important that you make sure these areas are kept clean and free from obstruction and also lint or any other debris. So if the docking ports are clogged up, of course, you're not going to get any water flowing and pressure flowing through your lumens if you're connected to the lower pipes. And if the drain is clogged up, you won't have the water draining out correctly, and which will ultimately have an aborted cycle at the end.
Hmm, thank you, Kurt. So when we were doing our research for this presentation, I came across this really interesting publication. It was about residual protein levels on dental instruments, comparing manual and ultrasonic and automated cleaning methods. And as we all know, that there's a lot of published papers that tell us that ultrasonic cleaning is better. Or way more effective, both automated and ultrasonic has very good effect. Yeah, they were looking at dental instruments, but one of the things that they had said in this particular bath that they were looking at, they had said there that the efficacy of an ultrasonic bath may have been compromised in that particular research because there were no periodic tests, no functionality tests, and no servicing. So we'll get to talking about servicing in the next slide, but obviously reminds us of the fact that it's really, really important to look after an ultrasonic bath if we expect it to be functioning correctly. Looking at the image on the right over here, Kurt, you and I saw that one day in the field, and we've seen this before a few other times as well. We look at the two things that stand out for me. One is the actual color of the tubes themselves. So, assuming that that tubing is now really quite old and looking terrible, but also the buildup of the gunk on the on that white manifold is incredible. I'm assuming that looks to me like a mold or a fungi that's grown. Why would we get fungi in our ultrasonic cleaner?
So this is, of course, leaving the water in overnight or over long periods of time. No one checking the water, and remember, this could be that we were in a hurry. It was change of shift. This is a manual ultrasonic cleaner, and in the example, and so with leaving that overnight, the lid is closed. There could be instruments in there. It could be no instruments, but just dirty water and solution that's been stuck in there, and the heat of the water condensates later, and it's dark. It's the perfect room and
Ideal
ideal.
ground for some mold, huh?
100%, 100%. And then draining the water, draining it out at the end, you're draining that mold down into the tubing of the ultrasonic cleaner. So in the inner parts that you showed earlier, you end up finding it in the certain pumps, and which we'll discuss later as well. So it's very, very important not to leave the water, as we mentioned earlier, and that's the buildup of the endotoxins.
So
But it
ideal
happens often.
that we actually make sure it's empty, we dry it out, we leave the lid open overnight.
Yes, and it's not a storage area for anything else that you want to put in there, because that we find we need to store something away quickly, and or so we close the lid, we put stuff on top of it, or we put something inside of it, and then the rest of the packing that we want to store is on top of the lid, hence the lid is closed. So the lid definitely needs to be open when not in use.
So we spoke about the importance that, well, they saw in the published paper, they said it's really important to service the ultrasonic. Is it such a complex device? Does it need servicing?
Yes. So you mentioned earlier about the dots, the transducers, as we can see in the photo. They are the chemical inlet ports. There's the chemical pump, the hot and cold water inlet valves. There's a drain valve. There's certain CPE pumps, the recirculation ports, and your PC board. These are all electronic and some movable parts, and it needs to be serviced regularly as per the manufacturer's instructions for use of the ultrasonic cleaner.
Oh, great. Thank you.
Sure. So sorry, can you just go back quickly
Oh,
again?
I'm sorry about that, Kurt.
Sorry. So I just want to show something. We spoke about the lid staying open. In
Mm.
those tubing, you'll find mold growing in the tube by the drain valve, and by that there's a CPE pump. You'll find mold if you don't leave. You'll find that growing in there.
Oh,
Hence,
no.
we'll discuss in the daily maintenance as well how we can get rid of that and
Prevent that
ensure
mold or get rid of
prevent.
it.
Yes, here we go.
Oh, right. Carrying on now
Right.
with our checks.
Yes. Right. So looking at this is an example of a certain brand's daily and weekly maintenance tasks that need to be carried out to keep the unit performing optimally. So starting with the daily checks, each morning we would want to first inspect that the lid and the lid seal has no damages or wear on it. This will help prevent leaks and ensure proper sealing during the operation. And of course, no aerosols that's been released. And we will check is always make sure that the chemical levels or your enzymatic detergent levels are correct and it's enough for the use for that day. Most times we'll find that there's either no detergent in the can, and everybody has continue using it. They do find out that the instruments are not coming out clean. first check is to always check the detergent levels to make sure. A lot of the ultrasonic cleaners do not have a sensor that actually picks up the level of detergent because there's a pipe running in there only and a pump pumping it out. So always check that. Then throughout the day, please wipe and clean all internal surfaces above the waterline to prevent any residue or buildup of the endotoxins and other buildups. So if it's above the waterline, that's above the fill line. Make sure it's clean because remember when the lid is closed, you get the ultrasonics going, there's bubbles, it creates little aerosols, it hits the top of the inner part of the lid. So please make sure you clean that, and then don't forget to clean the external surfaces, especially around the lid and the lid seal. And that will prolong the lid seal and ensure that it actually closes correctly and the sensors work correctly on the lid. So that's at the end of the day. And at the end of the day, please empty the unit if it's a manual unit, wipe it and dry it correctly, and leave the lid open. As we mentioned, it's to prevent the moisture buildup and bacteria growth during the night. And sometimes you get unpleasant smells when you open it up in the morning. It's from that bacteria growth. Moving on to weekly checks, follow the manufacturer's instructions for use for weekly checks. As I mentioned, this is an example which I'm discussing. So once a week, do a detailed inspection. Make sure the power cord isn't trapped or damaged, and make sure it fits securely in the socket. So with that, sometimes the power cord, because we clean the tabletop or the worktop where the ultrasonic is sitting on, we move it, we push it back and we pinch the power cord. That's very dangerous. There's water close by and it's a cracked cord. It's very dangerous. So always make sure you check that, and then check that the water supply hoses are also not pinched. There's no wear and tear on it, and they're not cracked for any leaks. Inspect the drainage system. So if you have an overflow pipe and a drainage pipe, ensure that there are no leaks on those pipes. And then finally, depends on the manufacturing instructions we use, run a full decontamination cycle once a week to maintain the internal hygiene of the ultrasonic cleaner, which I just mentioned about those internal pipes that we saw underneath the unit. So make sure we run that. And for that, the best way to do it, if you take a small galley pot. So instead, for example, we can use on certain units, we can use the sodium hypochlorite based disinfectant, and we put it in a silver or a stainless steel galley pot, put it inside the basket, and you start the cycle. This will do a deep clean, and it helps with maintaining infection control standards as well in the CSSD.
So obviously also very important now, if you're using an automated cycle, it'll then drain after that and rinse out the bath itself. But if you're doing a manual cycle, it'll be important now to make sure that you rinse afterwards.
Rinse, 100% to rinse afterwards. As we mentioned, everything is with the rinsing afterwards.
Yeah.
And yeah, so even with the dry nut, I think with the manual one, it's always best to fill up clean water, run it through the system, and then drain it out, just to make sure that you don't have any buildup of detergent, which it creates quite a buildup inside the internal parts. And yeah, key message here is consistent maintenance prevents breakdowns, improve reliability, and keeps the equipment performing safely and effectively.
Well said. Absolutely well said. Thanks, good. So like all pieces of cleaning equipment, like our automated washer disinfectors, we want to make sure that the machine works effectively, and servicing is important. But we can, of course, use test devices to check that the machine is working effectively. We know that in the past we have spoken about it. It's in the CFSA's SOPs as well. We've spoken about using the foil test. So the foil test is indeed one method of testing efficacy of the machine. We use it, our technical staff tend to use that quite often. But the foil test is a little bit trickier, of course, because now we've got foil residues in the bath of the ultrasonic cleaner, which adds a little bit of a risk. So these days, of course, you can also get cleaning efficacy tests that are readily available from a multitude of suppliers. And ultimately, it is some form of indicator that will go inside of a holder. and that holder is then attached to an area of the basket in the ultrasonic cleaner. We would put this in with a normal cycle, and at the end of the cycle, the actual indicator should also come clean. Ideally, we want to place these indicators throughout the wash, throughout the actual bath, because we want to make sure that all of those transducers are working. If you only have one indicator, then make sure you move it around to the different areas. Ideally, if you can, perhaps on the first cycle of the day, you use more than one indicator, because we're testing to see if all those little pumps, all the transducers are in fact doing their job. That's why we looked at them from the underneath, that we could see what they look like. Again, I think a very important piece of equipment. There are some groups at the moment. I'm involved in an ISO committee that is busy writing a standard around being able to identify the most complex types of instruments. And I'm learning the most amazing information about what part of an instrument is more complex and what isn't. And we'll talk about that in some future webinars, I'm sure. And these complex devices are problematic, and we kind of sometimes make the assumption that all instruments are the same, and we just apply the same principle, but really they're not. And here's an example. This was an outbreak. It happened in 2011 is when the paper was published, but the newspaper reports were coming around 2009, etc. I remember it being on the news. It was, as you can see, in Texas. And it was this horrendous outbreak of Pseudomonas joint space infections that happened after arthroscopy procedures, after knee arthroscopies. And it was all traced down to retained tissue in the ports of the in and the outflows of the cannulas, and of course in shaver hand pieces as well. And I often ask myself, if we were putting our devices into the ultrasonic cleaner, if we were following the manufacturer's instructions for use correctly, whether this outbreak could have been prevented. So every time I read another research paper about an outbreak of infection, I start to realize the value of every piece of equipment we have. So it's not just our washer disinfector, it's also our ultrasonic cleaner, because it really, really works well for those complex devices, those little nooks and crannies that we really and truly can't get into easily. So hopefully, Kurt, we've managed to explain the value add of an ultrasonic cleaner. Of course, we've now spoken about why we need them, how automated can be more effective than manual, how they actually work, how to use them, and thank you very much for teaching us how to look after them. Thanks, Kurt.
Sure. Thank you.
Thanks, everybody.
Thank you, everybody.
Thank you then. Cheers.
Bye.